Physiology of posture. To understand posture, we shall know first what is the tone. It is partial state of contraction of muscle at rest, also called as resistance of muscle to the stretch. Now what is the posture? It is basically adjustment of tone for various body movements. This adjustment is reflexly, so they are called as postural reflexes. Means when a person is standing, walking, talking, or doing any activity, constantly there is a change in tone of a muscle to adjust the body position. For example, I am writing on this whiteboard with a chalk, but what I need, even if I am doing a movement at my fingers and wrist, but I need to stand straight. I have to do some movement at my shoulder, then at my elbow joint, then at the wrist, then at the finger. So even if fingers are only making a movement, but there has to be a change in muscle tone in all this wrist, elbow, shoulder, and on my body. So this adjustment is reflexly, that's why these are called as postural reflexes. Again, to come back, everything is now converging down on our spinal cord. So we should know again something regarding spinal cord again. This is the muscle spindle, sensory nerve, our alpha motor neuron which is supplying the extraphyseal fibers. These are the gamma motor neuron which are supplying the muscle spindle. Now if we excite the muscle by giving a tap, this will get stretched. This will lead to generation of action potential in the muscle spindle, which will travel from sensory nerve again back from alpha motor neuron to lead muscle contraction. It is called as a reflex action. Now if descending tracts are exciting alpha gamma motor neuron, they will stimulate the muscle spindle, leading to generation of action potential in muscle spindle. Now this will again contract the muscle indirectly through sensory nerve and alpha motor neuron. And if descending tracts are stimulating alpha motor neurons, this will directly excite the muscle. That's why alpha motor neurons are also called as final common pathway. Now this stretch reflex in this diagram I am showing at different levels. This is the muscle which is having a sensory and motor nerve from the different body parts, maybe upper limb, chest, abdomen, thorax, lower limb. This group of muscle I am showing from the neck region. This is from the head muscles. Now this I am representing one muscle from each segment on either side, from head region, from neck region, from the whole body. This is our brainstem, midbrain, pons and medulla, and this is our vestibular apparatus which is sensing the balance and equilibrium for the body. Now these are the descending tracts which are coming from the pons and medulla from midbrain. They are ultimately ending on either alpha or gamma motor neuron. Now this all descending tracts are basically influencing down on the either gamma or alpha motor neurons of these groups of muscle. Means suppose I am writing on this whiteboard, so I need changes in my elbow joint, shoulder joint, wrist joint. Maybe biceps is contracting and triceps is relaxing. There is a contraction of flexor muscles, but there has to be relaxation of extensor muscle. So from different centers reflexes are coming. Basically ultimately everything is constantly coming and changing the tone in muscles, but as in intact animal many reflexes are not visible. Just like simple example, now we are having a light in the day. What tube is there? Tubes of different, a zero bulb might be there. Even your mobile has got some light, but this mobile light is not significantly visible in the daytime, but in the night when everything is closed and light is gone, no zero is there, no electricity, that time you just make your mobile on, your room gets illuminated. It's that much light it is having, but it is not visible in the daytime to us. We are unable to differentiate whether the mobile is on or off. Similarly, all the body muscles in the head neck region, body muscles, tone is constantly changing when you're doing body movement, but distinctly we are unable to see them. To find them, what we have to do, just like if you close the light in the night, we can see the importance of mobile light. Similarly, now we'll make sections in the different part of the brain, and to find it out, tone how it changes in different group of muscle from which part of the brain. So basically, somatic motor activity depends on patterns and rate of discharge of lower motor neuron or our alpha motor neuron. These neurons are bombarded by impulses from the descending tracts. So it is integrated activity of these multiple inputs from spinal cord, from the medulla, from the midbrain, and from the cortex. Now different reflexes are coming and they're changing tone in different groups of muscles to adjust the body posture. That regulates the posture of the body and make coordinated movement possible. Posture is continuously adjusted not only before but also during the movement by descending brainstem pathways and peripheral afferents. In intact animal, individual motor responses are submerged in total pattern of motor activity. Just like I have told, mobile light is not visible in the daytime. Similarly, all responses are submerged in intact animal. To find them, we have to do experiments. So now we will do experiments and try to find what is the regulation of posture from different part of the brain. That is from the spinal cord, from hindbrain, and from midbrain. So let's start with, we'll go from down to up now. We'll start first from the spinal cord. So in this, we'll do a section at lower part of brainstem. That means only the spinal cord is intact, remaining all influence from cerebrum, pons, cerebellum is gone. So this animal in which only spinal cord is intact is called as a spinal animal, or this preparation is called as spinal preparation. Means in this diagram you can see we are taking section at this lower end of medulla, only spinal cord is intact. Now we'll try to elicit different reflexes in this animal and we'll try to find which are present and which are absent. To start with, now we are giving a tap to one of the group of muscle in the body. We are given a stimulation now, impulse generated, it will travel to the spinal cord, it will come back and lead to contraction of muscle. So this is called as stretch reflex. That means stretch reflex is the most basic reflex present in the spinal animal. That means its center of location is spinal cord. This stretch reflex. Now second, in same spinal animal, what we'll do now, we'll stimulate some of the flexors, giving a tap to the muscle, impulse generated, it will go to the spinal cord. Now see what happens. It will excite opposite side muscle also, that are the extensor, and they will also contract. You can see both are contracting, means flexors of one side, extensors of opposite side. It is called as crossed extensor reflex. So in this classically you can understand a person is walking on barefooted, suddenly you can see there is a prick by a glass piece. Reflexly you can see here there was a flexion of the knee joint. So these flexors are stimulated. You can see now impulse is going from here, prick, there is a contraction of flexor. Instantaneously impulse will go to the opposite side, extensors contract to support the body. So it is crossed extensor reflex. It is a natural reflex, means whenever flexors of one side are stimulated, extensor of opposite are stimulated to support the body. But normally it is not visible. We are unable to see contraction. But when you see a spinal animal, you can classically see if you are flexing the flexors of a knee on one side, immediately you can see the extension in that animal that becomes visible. So this is cross extensor reflex. Again, one more experiment we will do on this in the spinal animal. Stimulation to the one of the muscle, You can see impulse generated here, travel down the spinal cord. On the same side, now it will excite one certain group of muscle. Impulse is going down here. You can see now one is contracting, other is relaxing. So this classically we need, when one of the muscle is contracting, antagonist must relax. For example, when biceps is contracting, there must be relaxation of triceps muscle. So this is called as reciprocal innervation. So this is again happening reflexly under normal condition, but classically visible in spinal animal. So this reflex is called as reciprocal innervation. So now this, you can see in this also, impulse generated from here going and leading to contraction of a muscle. It will again go to opposite side and relax the antagonist muscle. So that means when flexors are contracting, antagonist extensors must relax. So in the spinal animal, we're able to see stretch reflex, crossed extensor reflex, and reciprocal innervation. So these three reflexes are regulated at the level of spinal cord.